So let's talk about perpendicular bisectors. So what is a perpendicular bisector? I have a line segment. That is, it has a start and it has an end. If I want to divide this into two equal half, so one of the ways of doing it is with perpendicular bisectors. So it's a line which will cut this entire length into two equal half, and this line will be a perpendicular line. So that's why it's called as a perpendicular bisector. So how do we do this? It's quite simple actually. So we have a line segment of any length, doesn't matter. So take more than half with your what is it? Compass. Yeah. Take a measurement in your compass which is more than half the length of AB. Cut one arc with A as the center. Cut one arc at the top of the line and bottom of the line. And with B as a center, cut two arcs again and join them, and you'll get a perpendicular bisector. So let's see this practically. Okay, on a sheet of paper, how to do this. Let's see that. So we have a sheet of paper. So I'm drawing a long line, taking that as a starting point, and I taking 8 centimeter will bisect 8 centimeter. So you need to be sure of which is the starting and which is the ending point. Then with more than half the length, okay, so with more than half the length, we should draw two arcs, one at the top and one at the bottom. And flipping the paper, draw two more arcs with other point as a center. So we can see the arcs are intersecting. If they are not, we should see to that they do. So with those 2 points as the centers, draw a perpendicular line. Okay, I mean by default that will be perpendicular. So I'm showing you guys the verification. You can clearly see 0, 4 and 8. So we have bisected, that is cut the line into two equal half, and the line which bisected it is perpendicular to AB. So steps of construction, so that we kind of concrete the idea. The same thing, whatever we did, I'm just showing it as steps of construction. So the same diagram, I've scanned it, taking A and B as a center. So we have A and B which is 8 centimeter apart, and a radius more than half of AB. That's very important. Draw arcs on both sides of the line segment, up, top and bottom of AB. Let these arcs intersect each other at P and Q. So this is P and Q. So let PQ intersect AB at M. So that's M. Then line PMQ is required perpendicular bisector of AB. Okay. Now let's justify whatever we have done mathematically using congruency and all of that. Let's justify this. So for justification, you need to join AP, AQ, QB and PB, right? See, we can tell that all the sides are equal, so that makes it a rhombus, right? It's a rhombus, is it not? The rhombus diagonals bisect each other at an angle of 90 degree. So that is one proof. But if they want you guys to use congruency and all of that, this is how you guys do it. So first we'll talk about, consider triangle APQ, this entire triangle, okay, this part of the triangle. And again, other part of the triangle. Both have to be considered. And triangle PQB, they are congruent, is it not? Simple reason being PQ is common and AP or PA is equal to PB and AQ is equal to QB. So all these are of same length. We have constructed that in all of this in this way. So okay, so this is there, and now how to put it across. Therefore triangle PAB or PBA is congruent to triangle PQB by SSS congruency. So with this we can tell that angle APM is equal to angle MPB CPCT. So these two triangles are congruent, so I'm telling this particular angle is equal to this particular angle. Okay, so with that in mind, let's consider PMA triangle and triangle PMB. So here PM is common and we just proved that angle APM equal to angle MPB. This is from 1. Then we have what else? AP is equal to PB. This is because of construction. And so what can you tell? These two triangles are therefore by what congruency? Yes, AS congruency. Triangle PMA is congruent to triangle PMB, right? So we can clearly tell that this implies AM is equal to MB, okay, CPCT, and also that and also angle AMP is equal to angle AMB. Okay, so why is that we are doing it? We have proved that yes, it got bisected. We have to prove that it's perpendicular also. So now angle AMP plus angle BMP, both of them are equal to, the sum of that is equal to 180 degree. So why is it so? Because they are linear pair. And from equation 2, which is over here, so we'll tell from 2, so these two are equal, so we have 2 into angle AMP is equal to 180, so this is equal to 90, and that's your justification that this is equal to 90 and it's a perpendicular bisector. Okay, so please write the heading perpendicular bisector. So you need to construct this using steps of construction, and if you want to watch the video again, the part of the construction, watch it again and construct it along with me, and end of it verify also using your scale and compass and protractor and all of that, and end of it justification. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. there would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.